Hello everyone, my name is Keshashwini and I am studying in third year of engineering in ECE department at SRIT College, Anantapur. So today I am going to explain you one of the topic in machine learning subject, that is fineness algorithm and version spaces. Let's dive into this topic. So as I told you before, the topic name is fineness algorithm and version space. These are two algorithms, and now I'll tell you the introduction of these two topics. So here the fineness algorithm and version space are important methods in machine learning for concept learning. So both algorithms are used to generate a hypothesis from giving training data. Find works only on positive examples, while version space use both positive and negative examples. So these find algorithm and version space both are used to find the like examples of a concept. Like these used to find the problems using specific algorithm. So these are two different algorithms. So this find algorithm is works only. So this algorithm only works for the positive examples, whereas version space works for both positive and negative examples. So this finds the most specific hypothesis, whereas version space maintains all consistent hypotheses. These finders with or with the most specific assumption. This is the step by step. These both or algorithms are the step by step process where we can solve a particular type of problem. Okay, next. Now we'll see what is this finders algorithm is. So this finders algorithm is a concept learning method in machine learning used to determine the hypothesis from the training data. So it what it actually does is that this find the most hypothesis like relevant information that correctly classifies all the positive examples. Where I have told you before, this only works on the positive examples but not on the negative examples. It works only on positive training examples and ignore negative. Yes, and it is a hypothesis represented as, for example, if we take that H is equals to H1, H2, H3, and so on, and Hn, where this is all the, this classifies all, this specifies only the positive examples. Uh, each Hi represents an attribute value in the data set. This hypothesis is represented as here shown. In this method, it is represented where hi is each attribute value. Uh, in this, we also use these two specific symbols, that is this phi symbol and question mark, where this tells the most specific value, and the question mark tells the most general value. So, in two subtopics, we will divide this problem and we'll solve that. Like if we divide by calculation of each step and each example, we'll divide both. Like for specific value as yes and also generic value as G. Now we'll see how to find this algorithm step by step. Initialize the hypothesis with more specific values. First we have to initialize and then we have to select only first positive examples from the data set, and next we compare with the current hypothesis. We'll do the comparison, and for each attributive value in the examples, so for each variable that we have taken from the data set, we'll just check like if the hypothesis value is from 5, replace with example value. If the hypothesis value match with the example, so no need to change. Or next, if the hypothesis value doesn't match, so it replace with question mark. This is how we'll replace the data set variable with the two 5 and question mark. Next, what we do is that we update the hypothesis after processing each positive example, and we'll just repeat this all examples step by step to continue the whole process. This is how we find the S algorithm, and we see version space is a concept learning method in machine learning that represents all possible hypotheses consistent with training data. So this, as I told you before, this uses both positive and negative examples, and here we use two boundaries, that is S and G. S for specific and G for general. So these works for both positive and negative values. It provides a complete and accurate learning model. So now we'll see what are these S and G boundaries and how do we use inversion spaces to solve the particular problem. Now we'll see SMG boundaries. So S is a specific and G is the general boundaries here. Version space is represented using two boundaries, specific and general in machine learning. Here, as we see, Yes is a boundary represents the most specific hypothesis initialized as. So we'll set the boundary of S with 5 and G with question mark. If we take hypothesis of the like different variables from the data set, like the combination of both positive and negative values, when a positive example X is given, S generalizes as X comma X and remove inconsistent hypothesis from G. It removes inconsistency from G. If we take negative example, G specializes, so G comma X, and we remove inconsistent hypothesis from yes. This is how it works in SNG boundaries in version space. So the space between yes and G, all consistent hypothesis, version space. If yes is equals to G, then hypothesis is obtained. Then we can find that this problem is solved using version space by SNG boundaries. Now we'll see the uh, comparison, like how it works. So here, if you see that the difference between finders and virtual space, data use and all, so the computational cost is here low and here it is high. The type of this is single hypothesis and maintained set of hypothesis. So this is the difference between both finders and the virtual space. So the conclusion part is that finders gives one simple rule, that is while virtual space keeps all possible correct rules, helping machine learning better. So this finders algorithm focus on learning from positive examples, whereas a version space consider both positive and negative examples where we can get accurate values easily. Thank you.